Let's do an example where we solve for the competitive equilibrium. Remember, the steps here to calculate the competitive equilibrium are to first calculate the demands for both Rob and Friday for arbitrary prices. So take any arbitrary prices PA and PB, the price of apples being PA, the price of bananas being PB. Find the demand for apples for Rob and find the demand for bananas for Rob, and do the same thing for Friday. The next thing to do is to add together Rob and Friday's demands for apples to get the aggregate demand for apples. Then, or in other words, the market demand for apples. Add together the uh, demands for bananas for Rob and Friday to get the market demand or the aggregate demand for bananas. What we then do is that we want to find the prices, PA and PB, such that we have equilibrium in both markets, right? So we want the market demand or the aggregate demand to equal the total supply in the market, which is the total amount that's available in each of the markets. Right, so we look for those prices such that we get equilibrium in either of the two markets, in both of the two markets. Well, once you have that, then we just find what each person's demand is at those prices, and that's our equilibrium. And then just to make sure, we can go back and verify that the market's clear. Right? Now, Walras law tells us you can, as long as one of the two markets clears, the other market clears. But when you're doing this as an exercise, you might want to check both of them as just as a backup to make sure that you haven't made any mistakes. Now, a shortcut that you can take here is that when you're solving for the competitive equilibrium, the only thing that matters, if you go back to like the pictures we drew in the previous clips, and we were trying to find the competitive equilibrium, we only needed to adjust the slope of the budget line. We just rotated it around, but it was fixed. It always pivoted around the endowment point. So the only thing that changed was the slope of the budget line, and the slope is minus PA over PB. So as long as PA over PB varies, that's the only thing that you need to worry about. So what you can do is you can just fix one of the prices to have the price 1, and then vary the price of the other good. So if we just fix the price of bananas to be 1, and then you say, okay, I'm just going to vary the price of apples, then what you're doing is that you're just going to vary the relative price of apples to bananas. Okay, so this is a shortcut that we can take so that we just have one variable that we need to solve for. Okay, so let's do an example. So our example is where Rob and Friday have those preferences that we had seen in prior clips, and the endowments are what we had seen before, right? So it's 20 apples and 30 bananas for Rob, 60 apples and 20 bananas for Friday. And they both have the same utility function, which is just the product of the number of apples and bananas that they consume. So the budget line for Rob is this, and the budget line for Friday is this, right? It's just the price of apples times price of bananas. The price of apples times amount of apples plus the price of bananas times amount of bananas that Rob consumes has to equal his income, which is the number of apples that he has, which is 20 times the price of apples, plus the number of bananas that he has times the price of bananas. And similarly for Rob to get his budget equation over here. To solve for Rob's demand, what we're going to do is we're going to set the marginal rate of substitution equal to the price ratio. Remember, the marginal rate of substitution for this utility function is just BR over AR. Now the price ratio, technically it's minus BR over AR. If we've set the price of PB equal to 1, then the slope of the budget line is minus PA over PB. And if the denominator is 1, then we just get minus PA. So if we set minus BR over AR equal to minus PA, that's equivalent to just having BR over AR equals PA. In other words, BR equals PA times AR. Right? We just multiply both sides of this equation. We multiply both sides of this equation by AR. So we get BR equals PA times AR. Well, what we can do is we're going to plug this into his budget constraint. Right? So this, instead of BR, we know that that has to be equal to PA times AR. But PB, remember, is 1. So PB times BR is just PA times AR. So we have here PA times AR plus PA times AR has to equal the right-hand side of this budget equation. In other words, 2 times PA times 2 AR has to equal 20 PA plus 30. So if you solve for that, so let me just write that down here, 2 PA times AR equals 20 PA plus 30. We can divide through by 2 times PA. The 2 PA cancels here. This becomes 10. 15. So therefore we have AR on the left side, and on the right hand side we have 10 plus 15 over PA. You do the same thing for Friday, right? We would get a similar equation for Friday, and we plug that in. We plug in the similar equation to substitute for PB times BF, and then you solve for AF, and you're going to find that AF is 30 plus 10 divided by PA. Okay, so now we have the demand for apples for both Rob and Friday. The next thing to do is remember that we need these to equal the total supply. Right? So we know what the demands are, and we want the total demand equal to total supply. Right? So total demand is Rob's demand for apples plus Friday's demand for apples. So Rob's demand is 10 plus 15 divided by PA. Friday's demand is 30 plus 10 divided by PA. We need that to be equal to the total supply, which is 80. So if we add these together, 10 plus 30 is 40. We subtract 40 from either side, we get 15 plus 10 divided by PA, which is 25 divided by PA, equals 40. So PA has to be 25 divided by 40, which is 5 divided by 8. So then we know what all the prices are. The price, remember we had fixed PB to be 1. So the prices are now, we've solved for the prices as being 5/8 and 1. So then we can go back to our demand functions, right? We'd solve for the demand for apples of Rob and Friday. We could plug in the price of apples, which is 5/8 for both these guys. So plug in 5/8 here, we get 34. We plug in 5/8 here, we get 46. So now we know how much apples both of Rob and Friday demand. Well, if we want to get their demand for bananas, well, we could just go back to their budget constraints. That's one way to do it. Right? We know how much their incomes are. Right? Rob's income is, remember, 20 times the price of apples plus 30 times the price of bananas. Price of bananas is 1, price of apples is 5/8, so this is his income. Now we know he consumes 34 apples, and the price of apples is 5/8. The price of bananas is 1. So on the left side of his budget equation, there's just a BR. So we've got 5/8 times 34 plus BR has to equal his income. Similarly, we've got this, an equation for Friday. Solving for BR, the optimal BR is going to be 21 1/4, and solving for the optimal number of bananas for Friday, we find that it's 28 3/4. Now, it just so happens that if we add up the demands for bananas, we get exactly 50, which is what the market supply of bananas is. In other words, the market for bananas clears. All we did so far was to look at the demand for apples and find the prices such that the market for apples cleared. We didn't really look at the market for bananas or worry about clearing the market for bananas, yet the market for bananas clears. Well, that's the magic of Walras law. Right? So Walras law told us that that was going to happen. But it's good to check this anyway, just to make sure everything works out. Okay, so the competitive equilibrium here is a list of prices. We've got those prices. 5/8 is the price of apples, 1 is the price of bananas. An allocation for each consumer. So we've got 34 apples and 21 1/4 bananas for Rob, 46 apples and 28 3/4 bananas for Friday. Now we can plot that on in the picture in an edge width box. We've got our endowment. Our endowment right here. We have a budget line, which has a slope minus PA over PB, so it's a slope of minus 5/8. And when both consumers maximize their preferences, then they look at their optimal bundle, they choose bundles so that the market's clear. So Rob is going to choose 34 apples, 21 1/4 bananas, and Friday is going to choose 46 apples and 28 3/4 bananas. And this works out perfectly. Those prices, 5/8 and 1, are just so that the total number of apples consumed is equal to the number of apples available, which is 80, and the number of bananas consumed is exactly equal to the number of bananas available, which is 50.